this is a summary type of lesson. Okay, we're going to take all the knowledge that we've been working on and kind of package it up and make it into one. Okay, so before, when we were talking about the sine, cosine, and tangent with a unit circle, we gave you a very slimmed down version of it. But of course, we're not always going to be restricted to a unit circle. So when we said that the sine of t was y, we were giving you an incomplete story, okay? Because that only worked with unit circles. Now we want to talk about any old circle of radius r, okay? If the radius is r, when we're trying to find the sine of a reference angle, sorry, I have to reorient my smart board here. Let's stop this for a moment. Go out, come back in. So if we drop a perpendicular from that point to the x-axis, then this vertical distance is how far up I am, and this horizontal distance is my adjacent to this new angle that I'm talking about, this reference angle, theta prime. And this number is no longer 1, it's the radius of any old circle. Okay? So when we see this, we recognize that we have a right triangle, and we can use Pythagorean's theorem, x squared plus y squared equals r squared. So to simplify it, we're going to just say simply that r is equal to the square root of x squared plus y squared. Okay? So once we do that, then the sine of this new theta, this reference angle for our theta, is going to be the opposite over the hypotenuse, the SO of SOHCAHTOA. And so now it's y over r, not just plain old y. And the cosine is going to be the adjacent over the hypotenuse, so it's going to be x over r, not just plain old x. The tangent doesn't change, it's still y over x, and the reciprocal functions will adjust accordingly. Cotangent will still be x over y. Cosine will now be x over r. Sorry, the secant will now be r over x, and the cosecant is the reciprocal of the sine, r over y. Okay, provided that we don't have zeros in the denominators. So far, so good? Okay, so we have an ordered pair now. That ordered pair is 7, negative 4, and it's a point on a terminal side of an angle theta. Okay, so if we sketch this, we are 7 over 4 down. That 7, negative 4, is a point on the terminal side of a ray. Here's my initial side. So here's my theta. And we want to find the sine, cosine, and tangent of that theta. Turns out it's going to be the sine, cosine, and tangent of that reference angle. Okay? So we know the x value. We know the y value. What do we need to find first? R. So R will be equal to the square root of 7 squared plus a negative 4 squared. So 49 plus 16 is how much? 65. So we'll have the square root of 65 as our R. Okay? So now that we know x, y, and r, the sine of our theta prime, of our reference angle, is going to be the y over the r. The y part is the negative 4. R is the square root of 65. And we can't leave a radical in the denominator, so we're going to have to rationalize it and call it negative 4 square roots of 65 over 65. The cosine is always x over r. So the cosine of theta is going to be the 7 over square root of 65. And that's a 7 square roots of 65 over 65. And then tangent is still y over x. So the tangent of theta is going to be negative 4 over 7. So questions on this one? Okay. So that's no big gap, or no big leap here, no big giant leap. It's just that we have to find out what r is first. It's not going to be an understood 1. It's not a unit circle. Okay. So here we go. So the next thing we need to be aware of is that we're going to be talking about those reference angles and using them as a way of finding measures of our trig functions, our ratios of our trig functions. And in this first quadrant, all of our trig functions are going to be positive. Sine, cosine, tangent, cosecant, secant, cotangent. In the second quadrant, sine and cosecant are positive. And the way to remember these is all students take classes, right? So in the third quadrant, tangent and its reciprocal are positive. And in the fourth quadrant, cosine and secant are positive. Okay. Easy way to remember them. All students take classes. All are positive, sine and cosecant, tangent and cotangent, and cosine and secant. All right, so if they tell us that cosine of theta is 2/3, and the tangent of theta is greater than 0, tangent of theta is positive. First of all, which quadrant do we have to be in? Upper right, first quadrant. Because both cosine and tangent are positive, that has to be first quadrant. So now we want to find the cosecant of theta. So cosecant is reciprocal of sine. So we want to find the sine, or basically take the hypotenuse over the opposite. Okay. Right, opposite over hypotenuse for sine, and for the cosecant, then we'll want to find the hypotenuse over the opposite. Okay. Yep, we have the hypotenuse, right? Here's our r, and this is our x, right? So we just need to know what the y is. So r squared equals x squared, the square root of x squared plus y squared. Okay. So 9 minus 4 is 5. So we're going to have the square root of 5 as our y. Okay. So now the next step is going to be to, I guess, r squared, we don't need the squared here. Okay. R is the square root of x squared plus y squared. Okay. So we know that our y is square root of 5. And we need to find the cosecant, so that's going to be r over y, right? So the r was 3. The y is square root of 5. That's the cosecant of theta. And we have to rationalize that, so we'll get 3 square roots of 5 over 5. From the fact that the 9, the r, is equal to 3 squared. Okay, so we had, well, the other way of thinking of it is 3 squared equals 2 squared plus y squared. R is equal to the square root. Yeah, I tried to include it when I didn't need to. Okay, so far so good? All right, so next one. When we talk about something called a reference angle, we want to know where is this angle at with respect to the x-axis always. Okay? So we're used to our normal angles being in the first quadrant, but if it's more than 90 degrees but less than 180, and in the second quadrant, we always drop our perpendicular to the x-axis, never the y. Okay? And so if we want to know what this reference angle is, then we need to say, okay, well that's not 180, it's just short of 180 or pi, right? So we take pi minus that theta if it's in radians, or we take 180 minus the measure if it's in degrees. So if this was a 135 degree angle, then 180 minus 135 is going to get us 45. So this would be a 45 degree angle in the second quadrant. Okay. Likewise, if we're in the third quadrant, we always drop our perpendicular to the x-axis. So we're just a little bit more than 180, right? So we take our original angle theta minus 180 if it's in degrees and minus pi if it's in radians to find out what that reference angle is. Okay? So if you're in the second or third quadrant, you're either adding or subtracting from 180 or subtracting 180 from it to find that reference angle. And finally, in the fourth quadrant, we're almost to 2 pi or 360, but not quite there. So we would take 360 minus that angle, or 2 pi minus that angle if it's in radians to find the angle. So if this was a 330 degree angle, to find the reference angle, we'd take 360 minus 330 and find out that it's a 30 degree angle. We always drop it to the x-axis. Remember that from last year? Talked about reference angles last year. Okay, questions so far? All right. So now we want to find the reference angle for these four angles. Always, if it's in degrees, keep it in degrees. If it's in radians, write your answer in radians. Okay, rule of thumb. So if theta is equal to 144 degrees, think of where that's located. Quadrant 2. Because we're not quite to 180, right? We're somewhere over here. Okay? Probably made it too big. Somewhere over there. And so you're going to do a quick sketch of it if you need to visualize it. And if we're in quadrant 2, we're going to take 180 minus the 144. So 180 minus 144 is 36. So this is a 36 degree angle. That's our reference angle. Okay. Next one. It's in radians. We're going to keep it in radians. Okay. The minute you see a 4 in the denominator, you know that it's going to be a 4 in the denominator of radians. It's always going to be a 45. Yep, that's a 45 degree angle. Okay. So our reference angle, we know this is a 45 degree angle. Let's think about which quadrant we're in. So 1 pi over 4, 2 pi over 4, sorry, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, right? So we are in the quadrant 3. This is a 45 degree angle in the third quadrant. Okay. 7 pi over 9, do we recognize that one? No. Not over 3, not over 6, not over 4, right? Those are our special angles we need to know. The 7 pi over 9 is not. So think about 7 pi over 9. It looks close to 9 pi over 9, right? But not quite there. 9 pi over 9 would be 1 pi less than 180. So it's going to be somewhere over here, right? And so we would take 9 pi over 9, which is the same thing as 180, right? And subtract that 7 pi over 9. Yep. And that is our reference angle. Make sense? Adding to 180, subtracting from 180, adding to 360 is subtracting from 360. The next one listing, 1.7, okay? So no degree sign, right? So we know we're in radians, right? So this is pi radians, right? What's pi as a decimal? 3.14, right? So we're not to 3.14. Are we half of 3.14? 1.57, right? So we're not there yet, right? Or a little bit more, okay? So we know we're somewhere here. So what are we going to do to find our reference angle? Yep, 3.14 minus 1.7, right? Or just call it pi minus 1.7. And we know that we're in quadrant 2. I'll take it either way. Okay. It's a good idea to do that. That way you're mentally thinking, okay, which one is it? And then we'll use that to figure out whether the sign should be positive or negative by the all student state classes. Okay? Make sense? Questions so far? Okay. So, trig values of common angles. Okay? I can't stress this enough. There are 9 things that you need to memorize ASAP because it's going to make life so much easier for you. Okay? Which is why we gave you the unit circle, which is why we give you these tables, which is why we ask you to do this over and over and over again. Okay? Now see if I can find a Quizlet app or a Quizlet stack of flashcards that can help you. But those 9 primary angles, sine, cosine, tangent, 30, 45, and 60, are going to be very, very crucial that you get down. Okay? Becomes second nature. All right, so as we make our table, let me show you some shortcuts. Okay, so first of all, 0 degrees is how many radians? 0, we know that, right? Anytime we see a 30 degree, we know it's pi over 6. Yep, pi over 6, because 180 divided by 6 gives me 30. Anytime we see a 45, pi over 4, 60, pi over 3. We know 90 is pi over 2, 180 is equivalent to pi, and 270, 3 pi over 2. Okay, so those are quick. We don't have any problems with those. We made those connections. Now, one way you can do this with a table is you can put the ordered pairs up above. Okay, and we'll do that in just a moment. Okay, but let me show you how to count by square roots. Okay, it makes life so much easier. The sine of 0 degrees is the square root of 0 over 2. What's the square root of 0? 0 over 2 is 0. The sine of pi over 6 is the square root of 1 over 2. What's the square root of 1? 1. 1 over 2 is 1/2. You don't have to. I'm just showing. Yep, just showing you where it's coming from. Okay. The sine of 45 is the square root of 2 over 2. The sine of 60 is the square root of 3 over 2. And the sine of 90 is the square root of 4 over 2. What's the square root of 4? 2 over 2 is 1. And just reverse it, because the cosine's a cofunction, right? And it's going to be 90 minus it. So 90 minus 90 is 0, so the cosine of 90 is the same as the sine of 0. And then square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. It's not so hard to memorize those, right? Just counting. Okay? Now tangent. If we get to the tangent, it's nothing more than the sine over the cosine, y over x. So 0 over 1 is, and 1/2 over 3/2, it's going to be 1 over the square root of 3, right? So just remember that tangent of 30 has lots of 3's in it. Square root of 3 over 3. Okay? It ended up being 1 over the square root of 3, which we rationalize as the square root of 3 over 3. The tangent of 45, 1, because square root of 2 over square root of 2 over 2 is just plain old 1. Okay? And the tangent of 60, I take the square root of 3 over 2 divided by 1/2. I flip it. I'll have 2 over 1. The 2's are going to cancel. And we just get 1 3 here. Just 1 square root of 3. We got all kinds of 3's with the tangent of 30, but just a single square root of 3 with the tangent of 60. And then if we try to divide 1 by 0, what happens? Undefined, so not possible. Okay. Now let's think about 180 and 270. 180 and 270, I'm here, right? What's that ordered pair? -1 0. And what's this ordered pair? 0 -1. So the sine is the y value, right? So this is going to be 0. Cosine the x value. Tangent y over x. And then y value for the 270. X value for 270. Tangent y over x for 270. Yep. Because we can never divide by 0. Now we did that quickly. Did I lose anyone anywhere? Okay. Making sense? Remember these 9 core values, right? And the rest can fall into place by using our ordered pairs. Okay? But counting is a good thing. Okay? And we want to get to the point where I can say, you know, Robert, what is the tangent of 30 degrees? And you can immediately say, tangent of 30. Absolutely. Okay, it's the one that has all those 3's. Okay? You wanted to be able to quickly do that. And I've got some spinners. We'll use them tomorrow. We'll let you quiz each other. Have a table to the side and then just memorize them. Okay? Because it's just repetition. All right. So here we go. Evaluate without using a calculator. Okay? So here's where you want to kind of take a few notes. See if you can do it. Cosine -60. -60 means we're going backwards, counterclockwise. Okay? So now we're here. So if you remember the ordered pair there, by all means, you can use the ordered pair. Okay? Anybody know the ordered pair for this one? One half and square root of 3 over 2, right? And all students take calc, right? So which one's positive? Yeah, it's going to be a negative square root of 3 over 2, right? And the positive 1/2. Okay, that's one way to remember it. If you can remember your ordered pairs and you know the cosine is the x value, you've got your answer. Okay? I'm not going to tell you one method's better than another. But the other thing you can do is say, oh, wait a minute, that's a 60-degree angle in the fourth quadrant. Okay? So 60 degrees, fourth quadrant, means the cosine is positive, and I know the cosine of a positive 60-degree angle is a positive square root of 3 over 2, or 1/2. Sorry, 1/2. I'll throw you off. Either way, we get the same answer. Okay? The cosine of a 60 is 1/2, and I'm positive because I'm in quadrant 4. It's cosine. Okay? X and Y's, exactly. Yep, yep. The X is positive, the Y is negative, so the X is going to be, the cosine is going to be positive. Okay? Showing you multiple ways you decide what works best for your brain. Okay? That's fun. What kind of a reference angle is this? Dividing by 3, we have a 60. We know it's a 60-degree angle in some quadrant. Okay? And we can count, right? 5 pi over 3, we're counting by 60 degrees. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, right? 5 pi over 3. Okay? So we're in the fourth quadrant. Is sine positive or negative in the fourth quadrant? Negative. So we know we've got a negative something. And what's the sine of 60? Square root of 3 over 2. Okay, again, we could use that ordered pair if we memorize those, or if we know the sine of 60, and the fact that it's in the fourth quadrant makes it negative, we've got our answer. So these should be quick, okay? You shouldn't have to ruminate over them, okay? Next one, tangent 17 pi over 6. When we see the 6 in the denominator, we know what kind of angle? 30 degree reference angle. Okay, so yeah, take off 12 pi over 6. That's a rotation, right? Two rotations. What's left? 5 pi over 6. We've gone around 2 times, right? But now we've got to get 5 pi over 6. This is 1 pi over 6, 2 pi over 6, 3, 4, 5. 150 degree angle, if you want to think in degrees. Okay, is tangent positive or negative in this one? Negative, so we know our answer is going to be negative. What is the tangent of a 30 degree angle? The one with all the 3's, square root of 3 over 3. See how fast that is? Not when you take the test. And no reference, no unit circle and so forth. Mr. Clemenger and I are debating about whether to let you use a unit circle on your quiz tomorrow, on Friday. Because we have a pep rally schedule. Not for a while. We have to graph all these things first. Okay, so far so good? All right, so I think we can do this without any reference. I think if I gave you a blank unit circle so you could have it to refer to, you could fill it out if you wanted to or just kind of look at it, but I want you to get to that point. Just a minute, we're almost done. Okay, so let theta be an angle in quadrant 3 such that the sine of theta is a negative 5/13. Use the find the secant and the tangent using trig identities. Okay, I want to show you how to use trig identities because you can do it the other way, right? Finding r, actually we have r, finding x, right? But let's think about how we could use trig identities to do this. Okay, the sine of theta is negative 5 over 13. Okay. Sine and secant are not reciprocals, right? Can't just flip it. And sine and tangent could potentially come into play here, right? But where do we see secant at? Secant and tangent down here, right? Okay. So let's do something with Pythagorean theorem here, or the Pythagorean identities. Okay. The sine squared plus the cosine squared is 1, right? One of our identities. Let's square that. Let's take sine squared and let's take a negative 5/13 and square it. 5 squared is, 13 squared is, so let's take that 25 1/69 to the other side, right? Okay, so cosine squared will be equal to, well, 169 1/69 minus 25 1/69 is 144 over 169. So if the cosine squared is 144 over 169, what's the cosine going to be? 12 over 13. And if the cosine is 12 over 13, what's the secant going to be? And if the sine is negative 5/13 and the cosine is 12/13, what will the tangent be? Five 13ths over 12/13, right? negative 5 plus. Okay? Multiple ways you can do these problems. They specifically said trig identities, so we use trig identities. Okay? Very good? All right. So, does anybody need more practice with evaluating these in the calculator? What's the key thing to remember? Whether it's in radians or degrees, so check. If you're in degrees, you need to use degree mode. If you're in radians, you need to use radian mode. Okay? And if you're finding the reciprocal functions, it's 1 divided by, or use the reciprocal button, the x to the negative 1 button. Okay? All right. So, assignment.